all, we'll continue talking on the Arduino boards. So Arduino, basically we know we discussed in the previous videos. So it mounts 80 mega 328p microcontroller. This basically is a 8-bit microcontroller. So we have several bit-sized microcontrollers, right? So if you are a beginner, so there could be 8-bit, 16-bit, 32-bit microcontroller. 8-bit is a very preliminary microcontroller, and every beginner starts with the 8-bit microcontroller. So 8051, you might have seen 8051, right? Which is taught more in academics. So that is an example of 8-bit microcontroller. So there are several manufacturers in the market who do manufacture 8-bit microcontrollers. So 80 mega 328p is one from Microchip. Previously it was Atmel. Now it is acquired by Microchip. And then Arduino, basically supports a maximum clock speed of up to 16 megahertz. So if you see the specifications of 80 mega 328p, you will get to know what Arduino Uno is going to support. So the external clock that is connected to the Arduino, if you see here on the board, you have a crystal. It is here. So this crystal belongs to the USB controller chipset, and you can see a crystal here. This is a 16 megahertz crystal, which is the maximum external clock that can be supplied to Arduino Uno. And then the very important point. So this particular microcontrollers which we are working basically needs to support some memory. So that the user can write his program, and the program runs forever on the Arduino Uno board. So a very important section of a microcontroller is the memory. So every microcontroller has two different types of memories. Memory can be segregated into two types. One is flash, and the second one is the SRAM. So flash and RAM are very important for the microcontroller to run. So flash is a permanent memory, we know that, and SRAM is a temporary memory. Apart from this, there could be EEPROM, which is also a permanent memory that can be supported by some of the microcontrollers. So 80 mega 328p supports EEPROM of up to 1 KB, which is a very good amount. So the same thing basically, because 80 mega 328p is supporting 1 KB EEPROM, so that will be carry forwarded to the Arduino Uno board, because it mounts the same microcontroller, right? So EEPROM most of the times is used to store some of the configuration data, where you can keep them, and once the board is powered up, you can pull out and initialize some of the things which you need based on the requirement. So EEPROM is some of the microcontrollers have internal EEPROM. Some of the designs have to use an external EEPROM because the microcontroller doesn't support. But having an EEPROM is not a must, but it is a good to have feature, and definitely a very important memory. But as we mentioned, flash and RAM are the important memories which need to be present. And then this flash memory is segregated into two sections. One section holds a code called boot code, and the other section holds the application code. So what is boot code? What is application code? So boot code is nothing but when you power up the board, it is the first program that runs from the on the microcontroller. So this boot code basically directs the execution of the inside the microcontroller, and it actually points to where the application code is present in the program. So not only that, if you receive a brand new 80 mega 328p, and if you want to program it, it is the boot code inside the 80 mega 328p which helps us to reroute our application code to the flash memory where it has to be saved. So this boot code is a very very small code which is less than 1 KB size, which occupies space within the 32 KB flash which we have talked. And application code basically is our code where the user writes his program on the Arduino Uno board. Example, if you are blinking an LED, or if you are driving a relay, if you are reading something, or if you are writing an UART, SPA, I2C serial codes. So all these form part of the application code. Boot code is something which comes along with the chip, and generally we don't worry too much about it unless you have an application where you want to specifically save the flash memory from a particular area, or before the application code runs, if you want to do something, some operations. Like example, to start the application code you need some condition, so these conditional checks and all can be written inside the boot code. So a versatile programmers do play around this boot program, and definitely based on the project needs, professionals do write the boot program. If you are a hobbyist and if you are starting with the microcontroller, assume that boot code is something present in the memory, and which helps the application code to be loaded to the flash. And then, as we talked, this is the snapshot from 80 mega 328p, which gives, you can see here, the segregation of the boot section and the application section within the flash memory. So this is called the program memory, and this is how the segregation shall be done. So a specific portion of the flash memory will be used for boot code, and our user program shall reside in the remaining portion of the flash memory. This is very very important. So when you start programming microcontroller, you need to have a grip on the memory locations where these are saved. So for 8-bit microcontrollers, the low-end microcontrollers, this aggregation looks very simple. But if you go to high-level microcontrollers like the ARM Cortex and all, the memory segregation is little complex compared to this. So there you have more features, and we have videos in our channel for that as well, so you can refer those videos on the microcontroller, high-end microcontroller parts. And then another important thing, so let us assume I'm a beginner. I received the Arduino Uno board to just experiment and learn something. Okay, so I see that there is definitely a 16 megahertz crystal that is mounted on the board. So I am trying to use the default configuration, default codes which are present. So if you haven't configured anything, if you want to use the very basic code that is there, just reuse it. The one of the important point we have to remember is the default configuration of this 80 mega 328p is internal clock, which is basically an RC oscillator which supports up to a frequency of 8 megahertz. And then this 8 megahertz is divided by a divider CK div 8, and it generates 1 megahertz further. That means the actual system clock you get is 1 megahertz. So this is the default configuration. So the users can configure their frequencies to an external clock and have higher operation, as we mentioned, like 16 megahertz. So a very, very important point to remember. Please post if you have any questions on these particular videos. Please support us to help create more videos. Thanks for watching.